Hello everyone. Today we're going to talk about queues, and queues are very similar to stacks, and in terms of programming we're actually really close, and we've already implemented most of it. The things that have been implemented already are the unparameterized default constructor, the parameterized default constructor, the copy constructor, the destructor, a getter for the size, as well as our three miscellaneous functions that we talked about: print, search, and empty, and the four operators that we overloaded: equals, the double angle brackets used with standard cout, the double equals operator, and the not equals operator. And actually, our pop function can actually remain the same. What makes a queue different from a stack is how data is added to a queue, and it can be described with FIFO: first in, first out. So this figure shows how data is added to a queue. Here we're adding 8 to an empty queue, and notice how it's being added from the left rather than the right as it was with the stack. We add the 6 from the left, the 3 from the left, and the 2 from the left. Look how it's pushing, right? So if this is a linked list, you would think of it as adding a front node to a linked list. And this is what makes a queue different from a stack. For the most part, the rest is the same, and the proper terminology for adding data to a queue, we're going to call enqueuing instead of push. Here we'll talk about dequeuing, and this should look similar because this is how a stack operates. With the stack, we go to the other end of where we inserted with one end, and we pop whatever was pushed last. But here, whatever was added to the queue first is what's taken out of the queue, right? And this process for the queue is called dequeuing. So while it's pop with the stack, with the queue, we're calling it dequeuing. So now we'll take a look at the C++ implementation in our next video. Thank you.